Hi everybody, welcome back to Mathmax tutorial. Today we have seen again amazing integration example, and today example is integration in bracket 1 plus tan x bracket square dx, and we can find solution by using two methods. Okay, we can here discuss the method 1 and method 2. Let's do start method 1. Yes, okay, let I is equal to, this is the method 1 plus this is the tan x bracket square and dx. And we know that all related formula for this a plus b bracket square is equal to, we know that a square 2 times ab and plus b square. Therefore we can write the simplification by using this formula. Then we get here 1 plus this is 2 times tan x, and then plus this is we get tan square x bracket complete dx. Now here we can observe, here this is the 1 and this is the plus tan square x. Then we know that related formula for the 1 plus tan square x is equal to sec square x. Therefore this integration becomes, we can write this 1 plus tan square I can replace this is the sec square x term. Okay, therefore we get sec square x plus 2 times tan x and dx. Therefore we can find this separately, integrate of this function. Therefore we get, this is the integration sec square x dx. Then here 2 is the constant, and we can find the integration of tan x and dx. Got it? Yes, okay. Therefore we know that the sec square integration is equal to, we know that this is the tan x and plus here 2 is the constant, and integration of tan x, we know that integration of tan x dx is equal to ln, this is the sec x plus c. Yes, okay. Therefore here we get ln sec x plus c is the constant of integration, and this is my final solution by method 1. Yes, got it? Please note down it. Now we can find the solution by using method 2. Okay, yes, I can write given integration as it is 1 plus this is the tan x bracket square and dx. We know that the derivative of tan x is equal to, we know that all this is the sec square x. So I can here multiple throughout by numerator and denominator by sec square x, and divide this is the sec square x dx. And we know that the sec square x is equal to, therefore we know that this is the 1 plus tan square x is equal to also sec square x, and I can replace the sec square x is equal to term 1 plus tan square x. Therefore this integration becomes as, this is 1 plus tan x bracket square and divided by this is the 1 plus tan square x bracket complete into this is the term sec square x and dx. Now here observe, the derivative of tan x is equal to sec square x, and here present the term sec square x dx, we can here put substitution method. Yes, okay. Therefore substitute here tan x is equal to t, and we get this differentiate the function, we get sec square x dx is equal to dt. Therefore I is equal to, this integration becomes, we can write here 1 plus t bracket square divided by 1 plus t square, and here we get dt. And we know that all related this formula 1 plus t bracket square, that's mean this is we get 1 plus 2 times t plus t square, this is the simplification term, and 1 plus this is t square and dt. Now here observe 1 plus t square, this term I can here get separately write, and plus 2t and divide by this term 1 plus t square dt. And now I can separate this part, and then we get here this is term 1 plus t square divided by this is 1 plus t square plus this is 2 times t, and we get here 1 plus t square bracket complete and dt. Now here we observe this term get cancelled, therefore we can find only integration of 1 dt plus here we find 2 times t and 1 plus t square dt. Okay, yes. Now we can move the final solution, as we know that the related for this is the integration of 1, we know that this is the t only and this is the plus, right? And now here we observe this term here 1 plus t square, we get the derivative of this term is 2 times t, and here we know that these are the present this. Okay, and therefore we can write the, we know that all the f dash x derivative here present f of x and the dx is equal to, therefore we can only write ln of this function given and plus is the constant of integration. Okay, and therefore we can write here ln and function, that means this is the 1 plus t square and plus is the constant of integration. Yes. Okay, here can note down this formula I here use. Okay, and now back put t is equal to, therefore back put t is equal to tan x. Okay, and this 4 becomes integration, this is the tan x plus this is the ln 1 plus this is tan square x and plus is the constant of integration. Okay, and now we can write the simplification of this term, this is tan x plus ln and 1 plus tan square x, that means this is the sec square x and plus is the constant of integration. Yes. Okay, okay, and this is the my final solution. Yes, got it. If you like this video, please like, share and subscribe my channel. Thank you for watching. Bye bye. Yes.